How will the universe end? Our universe is 13.8 billion years old. It all started with the Big Bang, a simultaneous appearance of space in all directions at once. Over time, our universe has evolved and grown. Atoms formed, then stars and galaxies, and eventually planets, with gravity playing a significant part in their formation. We can watch the night sky and wonder about the nature of our universe. Will we be able to stargaze forever, or will the universe change? Will it ever end? The fate of our universe will be decided by the actions of three major properties: matter, radiation, and the vacuum. Observational evidence shows our universe is flat. There must be just enough stuff in the universe to keep it flat. Too much stuff and it curves inwards and becomes closed. Too little stuff and it curves outwards and becomes open. All the matter and radiation we see isn't enough to keep the universe flat. There must be other stuff in our universe which we call dark energy. The vacuum of space is not a true vacuum. It's full of virtual particles that constantly pop in and out of existence. The vacuum of space has its own energy, which may have led to the birth and inflation of our universe. As space continues to expand, matter and light become diluted, but the vacuum energy remains constant. This dark energy acts as an anti-gravity agent, stretching and flattening the universe. The amount of dark energy in a cubic meter of space is 1 billion times smaller than the energy released from a hamster falling 1 meter. However, it is this dark energy that will determine the ultimate fate of our universe. Our universe will undergo a runaway expansion. Galaxies will be pushed further apart, and eventually star formation will stop. In 100 trillion years, all of the stars will fizzle out like the dying embers of a bonfire. Planets will be ejected from their orbits and will be left to roam dark space alone. In over 1 trillion years, there will be nothing left except black holes. And eventually, as these evaporate, our glorious universe will turn into a cold, dark sea of distant particles where nothing ever happens. We will undergo heat death. However, this all depends on the true nature of our culprit, dark energy. It might change over time, becoming stronger. Billions of years into the future, stars and planets could be ripped apart by the ever-expanding universe. Even atoms would be destroyed in this rather painful Big Rip. Dark energy could go the other way and slow down expansion. The night sky would become ever brighter as space began to collapse. The temperature would increase, stars would explode, and atoms would be pulled apart. All matter would collapse into black holes, and the universe would end in a big crunch. Will the universe actually end? Did it ever really begin? The Russian-American physicist Andrei Lind believes we may be living in an expanding bubble amongst many other bubbles in a larger universe. Each bubble has a slightly different amount of dark energy and will evolve differently. It might be comforting to know that although parts of our universe may end, there will always be other parts where life flourishes in all its possible forms, on an eternal cycle, never ending.